In this video, we are again with the coordinate systems. This time we'll discuss the 3D ones. We will discuss about the Cartesian and the cylindrical. And in the following video, we'll discuss about the spherical coordinate system. So the purpose of this video is to introduce two systems, which are Cartesian and cylindrical, then understand unit vectors in these coordinate systems. So we have the 3D Cartesian coordinate system where we expand the horizontal xy plane with the z-axis. Then we have three perpendicular axes, which are x, y, and z. So when we want to move from the origin, as we discussed, any coordinate system has a point which we call origin, 0, 0, and 0 in 3D. We want to move to this point P, so we move in X first, for example, then we move in Y, so we move in Z until we reach the point. And we care most about the position, so the position vector will be the displacement in X, the displacement in Y, and the displacement in Z multiplied by the unit vector in each case. Now we care also about the infinitesimal components, such that we can do integration and differentiation. So in the case of infinitesimal lengths, it is simply the small quantity of x, small quantity of y, small quantity of z multiplied by the unit vector, so dxi plus dyj plus dzk. And this is the overall delta vector, which is delta L. And if we would like to know magnitude, we just take the square root. Now for the infinitesimal area, if we want to calculate delta S in the I direction, we just simply make cross product of delta Y in J direction and delta Z in K direction. So this will be my delta L1 and delta L2. So, and we know that if you do cross product, what you will get, you will simply get the perpendicular vector, and we know that J cross K equal to I. Similarly, you can do the same for other quantities, I mean in other direction, in J direction and K direction. But anyway, what you will get will be similar. And of course dy dz, because this was the scalar component here. Similarly, in J direction you will have dx dz, and in K direction we will have dx and dy. Finally, we have the infinitesimal volume, and in case of the infinitesimal volume, just you are multiplying the infinitesimal lengths in each direction. So you will have dv equal to dx dy dz. Now we move to the second coordinate system in the 3 dimensionals, which is the cylindrical coordinate system. And actually this system is just an extension of the 2D polar coordinate. We remember that in polar coordinate we have the radius rho and the angle phi, and then we expand this one again with the z direction or the k direction in z. So if we want to move from the origin to the point P, what we do, we just move with the radius rho, then we rotate with the angle phi, then we move perpendicular to this plane in the z direction until we reach the point P. Now we want to calculate displacement vector which connects the origin to point P. So this is our point P. I'm here in the origin. After rotation, this become my rho, and we are perpendicular with z direction. Now our D is here. We know this one is position here, this one is position here. So from vector calculus we understand that we can get this relation D. The vector D will be just rho multiplied by rho direction plus z multiplied by the k direction. Finally, just a note that rho is the vector pointing outward from the origin, and phi is just the rotation unit vector that points around the cylinder. So here just the tangent to this cylinder. And finally k is just unit vector in the k direction or z direction. The infinitesimal length, there is nothing special about rho and z. rho and z, just we have d rho and dz multiplied by the direction. Again, as we have discussed in the polar coordinate system, how to find the infinitesimal length in phi. Simply we imagine that we have a circle, right? And this one is rho and this is rho, and here this is the arc length, L arc. And what is the relation between phi and the L arc? Simply phi is equal to L arc divided by rho. Then if I would like to calculate d phi, I need also to take d of the L arc divided by rho. And if I reformulate this equation, I just multiply by rho. So I'll find that my L arc is equal to rho d phi, because this is length, phi is just angle. I cannot just place it here. So simply what you can find here, this is just d L arc. Then I simply can take the magnitude to calculate delta L as a length. And then moving to the infinitesimal surface area, again we just take the cross product of any two quantity. If I want to calculate in the rho direction, so I find dl in k and phi and multiply them to each other, then I can get delta s in the rho direction. Similarly, if I want to take in the phi direction, then what is the perpendicular plane, the plane which contains rho and k. So simply I go to my infinitesimal length here, I find the component relevant to rho, I find the component relative to k, then I calculate the delta s in the phi direction. Similarly, I can do this one in the k direction. Finally, again with the infinitesimal volume, simply it is just multiplication of infinitesimal lengths. So dv will be d rho, and then we have rho d phi. This was the delta L arc as a remainder again. Finally, we have delta z. So finally, we are with the takeaways of this video. We discussed the Cartesian and the cylindrical coordinate systems. Based on the problem, we need to select the right system. So if we have Cartesian, we can deal with box-like problem. If we have cylindrical, we deal with circular symmetry, basically around the z-axis. So based on the setup of the problem, and and we would like to simplify, especially we would like to simplify the mathematics which you are doing, so we select the appropriate coordinate system. Finally, with the unit vectors, we have fixed direction in case of the Cartesian coordinate system, just I, j, k, which is actually in the x, y, z direction. And in case of the cylindrical coordinate system, we have two vectors which depend on the angle phi, which are rho and phi, and we have one vector which is just a fixed direction, because just it is k, which is just in the direction of z. In the next video, we will discuss about the spherical coordinate system.